You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. The South Atlantic Anomaly. You've heard of the Bermuda Triangle. You may have even heard of its Pacific counterpart, the Devil's Sea near Japan. But did you know about the South Atlantic Anomaly? It's a region over South America and the South Atlantic Ocean centered at about 30 degrees west and 30 degrees south. And it's big, a little larger than the entire United States. Some say it's a danger to anything entering it, and they point most specifically to the crash of Air France Flight 447 in June of 2009, in which 228 people died. Whereas the Bermuda Triangle and the Devil's Sea are merely lines drawn on a map, the South Atlantic Anomaly is a measurable physical presence. Today, Skeptoid takes a look at what it is, what kind of danger it presents, and whether it really brought down Flight 447. To understand the South Atlantic Anomaly, let's start by taking a quick look at the Earth's magnetic fields and the Van Allen radiation belts. We all know that the Earth's magnetic axis is not the same as its rotational axis. As the Earth's molten ferromagnetic liquid core churns, it generates a magnetic field, and the north-south axis of this field is tilted about 16 degrees from the rotational axis. The North Magnetic Pole is in the North Canadian Islands, but it moves around a lot and it's currently headed northwest at about 64 kilometers per year. Here's the part that many people don't know. While the North Magnetic Pole is about 7 degrees from the North Rotational Pole, the South Magnetic Pole is about 25 degrees from the South Rotational Pole. A line drawn from the North Magnetic Pole to the south does not pass through the center of the Earth. Our magnetic field is torus-shaped, like a giant donut around the Earth. But it's not only tilted, it's also pulled to one side, such that one inner surface of the donut is more squished up against the side of the Earth than the other. It's this offset that causes the South Atlantic Anomaly to be at just one spot on the Earth. The anomaly itself consists of radiation. It is, in fact, the inner Van Allen radiation belt. If you picture the Earth as a circle enclosed within double parentheses, then bent those parentheses sharply toward it, you can visualize the shape of the Van Allen belt. The inner belt is shaped about like the letter C, while the outer belt is longer and almost completely encloses the inner belt and bends in sharply toward the magnetic poles. Since this whole field is tilted and offset to one side from the Earth, there's one point where the inner Van Allen belt almost touches the surface. This is exactly what the South Atlantic Anomaly is. The belts are shaped by the solar wind, and as the Earth spins within them, the offset causes the whole system to wobble, and everything is always in motion. This constant stirring is one reason the northern lights aren't static, they dance around. Correspondingly, the South Atlantic Anomaly observes a daily cycle, growing and shrinking and changing intensity, strongest at solar noon each day, and weakest around solar midnight. One result of the solar wind hitting the magnetic field is the creation of a cavity within the field called a Chapman-Ferraro cavity, and charged particles are trapped and collect within this cavity. These trapped particles are what the inner and outer Van Allen belts physically consist of. The inner Van Allen belt, where it comes closest to Earth at the South Atlantic Anomaly, is a cloud of energetic protons. Their energies range from about 100 kiloelectron volts, 100,000 electron volts, which is enough to penetrate half a meter of lead, all the way up to 400 mega-electron volts, 400 million electron volts, enough to penetrate 143 millimeters of lead. You would not want to stay there very long. In fact, this is one of the arguments made by the conspiracy theorists who say we never went to the moon. But the irregular shape of the Van Allen belts relative to the Earth provided part of the solution for the Apollo astronauts, in the form of a gap large enough to squeak through with only minimal exposure. The rest of the solution lay in Apollo's speed, and the astronauts cleared the belts in only 1 hour. Many satellites are not so lucky, though, and have to pass through the South Atlantic Anomaly frequently. Some 200 satellites currently have to deal with this. Many, like the Hubble Space Telescope, turn off certain sensitive sensors whenever they pass through. Electronics on such craft that are vulnerable must be shielded. The International Space Station also has this problem, but since it completes an entire orbit every 90 minutes, its exposure time is very brief. Also, only a few of its orbits pass through the anomaly. The total radiation exposure received by space station residents is within safe limits, though they've reported odd things like computers crashing when they pass through the anomaly. Scary stuff. We know that the South Atlantic anomaly is hazardous to electronic equipment and to humans who spend time inside it. We know that it dips down close to the Earth. So if we add these together, it suddenly sounds plausible that Flight 447 might have been taken down by it, right? Well, all by itself, wrong. Although the anomaly is a dangerous place, its edges are pretty well defined. The closest it ever gets to the Earth's surface is about 200 kilometers, and at that height, it's very small. The highest commercial aircraft might ever get is about 15 kilometers, and usually lower. Flight 447 was absolutely not, no way, impossible, not in the South Atlantic anomaly, either when it crashed or at any other time. The anomaly is in space. It's not in the atmosphere, and you're completely safe if you're below it and not in it. Your computers will not crash, your electronics will not fry, and you will not be baked by radiation. You'll never even know it's up there. Consider also that half of South America, including nearly all of Brazil, is directly underneath the South Atlantic anomaly. Aircraft fly safely throughout South America all day, every day. Computers, hospitals, and data centers operate here trouble-free year-round. There is simply no evidence, nor any plausible hypothetical argument, to suspect that the relative nearness of the Van Allen belts posed any danger at all to Flight 447. Moreover, Flight 447 had already cleared the area below the anomaly when it disappeared. Its last reported position was some 1,000 kilometers beyond the anomaly's northern reaches. It made it past the anomaly, then continued flying safely northeast for nearly 2 hours before whatever happened, happened. So how do we explain that little detail? The crashed airplane. The crash was investigated by the BEA, France's version of the American NTSB, the Bureau of Investigations and Analysis for the Safety of Civil Aviation. There's a link to their complete report in English on the online transcript for this episode at Skeptoid.com. Although the plane's flight data recorders have not yet been recovered, some data was received. At about the same time that it disappeared from radar, the plane's systems sent a burst of automated error messages to Airbus for maintenance purposes. These messages were almost all about inconsistencies between the 3 pitot probes that measure airspeed, almost certainly indicating that they were icing up. The plane was flying through storm clouds, though not a strong storm and not one to normally be concerned about, but evidently it was enough to ice up the airspeed sensors. In fact, a number of such automated error messages from other planes had prompted Air France to update the pitot probes on its Airbus 330s and 340s, and the replacement probes for this particular aircraft had been received by Air France 6 days before the crash, and were due to be installed. Analysis of the debris and the bodies showed that the plane was in cruise mode and that no preparations for a crash had been made. It belly flopped flat on the water, hard enough to kill the victims and destroy the aircraft. The BEA has determined that insufficient information exists to determine the exact cause of the crash, and they are in fact making plans to again try to recover the flight data recorders. A number of independent researchers have not given up on trying to pin the blame for the crash on solar radiation. On May 31st, earlier in the day, sunspot 1019 appeared. The principal danger of sunspots is a wave of ejected high-energy protons, which start arriving at Earth about 15 minutes after a solar flare event and continue for many hours. Could a burst of solar radiation from sunspot 1019 have knocked down Flight 447? It is absolutely a possibility, but it's not as strong a candidate as it may initially seem. According to NOAA's space weather report for the period, sunspot 1019 produced no flares on May 31st, and no proton events at all were observed. Flux was reported to be at normal levels, and geomagnetic activity was described as quiet. This reduces the possibility that solar or cosmic radiation caused the crash to pure speculation. It's improbable that a rogue particle or two could have caused a system error as specific as multiple inconsistencies reported by the airspeed sensors, especially given that icing from the storm cloud was a far more probable culprit. How this translated into the subsequent system-wide failures and crash is still unknown, but there's no evidence at this point that any external causes were at fault. Perhaps a future recovery of the flight data recorders will shed additional light, but for now there don't seem to be any questions about Flight 447 that can only be answered by the South Atlantic Anomaly. It's there, and it's real, and it does pose problems for spacecraft and astronauts passing through it, but all the information we have now indicates there's no reason for people on the ground or in the air beneath it to be concerned. Skeptoid is made possible by financial support from listeners. Come to Skeptoid.com and click on Support Skeptoid. You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com.